look at the assignment calendar that's posted on Google Classroom, we have 2 tests and then it'll be the final exam. And the nice thing is, I think you're really going to like this unit. It's pretty darn easy. So the first part is probability, and that's what we're starting with today. And then the second part is statistics. So you do mean, median, and mode. You've done that before. And you guys are going to do some box and whisker graphs and some scatter plots, all stuff I think you've done before. So it should be really easy, kind of a good way to end with some really easy stuff. So here we go. Today we're talking about simple probability, and we want to be able to calculate simple probabilities. And most of these probabilities we will be doing little experiments on. An experiment is an investigation. An investigation or procedure with varying results. It is an investigation or procedure with varying results. And so one experiment that often comes up in probability is flipping a coin. When you flip a coin, do you get the same head every single time? No, of course not. That would be really, really strange. So flipping a coin is an example of an experiment. And an outcome is a possible result from the experiment. And so, when we are flipping that coin, what is a possible outcome? You could get a head. You get heads. What else could you get? Tails. All right. And so those are possible outcomes that you could happen, one or the other. Not both, but one or the other. The sample space is, I'm going to put that in here, or tails, heads or tails. The sample space is the set of all possible outcomes. The set of all possible outcomes, so everything that you could get. So if we're flipping a coin, what are the possible outcomes we could have? Heads and tails. Those are the 2 possible outcomes we could have. And so that would represent the sample space. It's heads and tails. That's all we could get. That's all the possibilities. All right, so we want to give the sample space and the number of outcomes for each experiment. All right, a state that begins with the letter O. Oregon, O-R-E-G-O-N. What's another state with the letter O? Oklahoma and Ohio, Oklahoma and Ohio. All right, anything else, or is that it? All right, so that is the sample space. Those are the 3 possible outcomes that could happen. That's our sample space. And so if you were to name the number of outcomes we would have, are 3 total possible outcomes there. 3 potential outcomes. A day of the week. What is the sample space? The sample space is all the possible. What are all the possible outcomes? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. All right, so that is the sample space. Those are all the possible outcomes, the total number. And again, there are 7 different possibilities there. It's kind of a weird question. Don't really like it. So why do we need to know what the sample space is? Because when we know the sample space, then we can actually figure out the probability. Probability is a measure of the chance of a specific event occurring. The chance of a specific event occurring. Noted as P of E. This is the shorthand we use. This is the probability of an event. All right, that's what P of E means. Probability of a specific event happening. The probability is expressed as a ratio of favorable outcomes. What we want, that's favorable. What we want to the total number of outcomes. So probability of a specific event happening is really just the number of what we want out of the total number of possibilities, total possible. So it's what you want out of the total. It's a fraction. It's what you want out of what's possible. And that ratio can be written as a fraction, as a decimal, or a percent. And so we're going to recall how to do that. We did that at the very beginning of the year, convert things between fractions, decimals, and percents. So it's kind of like coming full circle here, ladies and gentlemen. Okay, so bottom line here, probability is what we want out of the total possibilities, okay? And if you can remember that, then probability is really, really simple. So give each probability as a fraction in the simplest form, decimal, and a percent. And so what we have here is a spinner. A spinner below is used in a game. If it's spun once, find each probability. So you'll notice that this spinner has how many wedges? 16 wedges. And it spins and it spins and spins and spins and it lands on a particular number. Some of these are shaded and some of them are unshaded. And so those are important things to remember or look at. And so this notation says, what's the probability of spinning a 9? So what's the probability of landing on 9? 1. So how many do we want? What are the wanting? What do we really want? A 9, and there's only one of them, right? Okay, so what we want, there's one choice that works for us out of how many choices? Out of 16. There's one thing that we want out of 16 possible choices. That is our fraction. How do we convert that to a decimal? Yeah, it is just division, ladies and gentlemen. This is 1 divided by 16. It is simply division. And so you put that in your calculator and we get 0.0625. So there is the decimal. Now, how do you convert it to a percent? Times by 100, or move the decimal 2 places. So we're going to times by 100. So we get 6.25%. Okay. Fraction, decimal, and percent. All right. This says, what's the probability of getting at least a 12? What does that mean to get at least 12? What would you want? What would be a good outcome? 12, 13, 14, 15, and 16 would all be favorable outcomes. To get at least 12, then 12 through 16 would work. How many favorable things is that? Yes, 1, 2, 3, 4, 5 winners. Out of how many possible choices? Out of 16. 5 out of 16. Let's see, 5 out of 16 is 0.3125. What is that as a percentage? Yeah, 31.25%. Okie dokie. On letter C, this is asking, hey, what's the probability of spinning a perfect square? Ladies and gentlemen, what are the perfect squares? Here's a perfect square of side length 1. What's its area? 1. Here is a square of side length 2, which is a perfect square of 4. What's another perfect square? 9. Very good. We get a side length of 3. So that gives us a perfect square of 9. And what's another perfect square? 16. Very good. So these are the perfect squares. I don't know. Have you ever watched Number Blocks? You guys? No? Oh, Number Blocks is the greatest show. They do perfect squares. You should watch it. It's so good. All right. So how many favorable outcomes are there? 4 good winners out of how many total options? Out of 16. Is this a simplified fraction? It's 1/4. Yeah, 4 out of 16. You could math frac that. It gives you 1/4. Of course, that is the decimal. 0.25. What is the percentage? 25%. Very good. Okay. What is the probability that you land on something that's not shaded? What's the probability that you land on something not shaded? How'd you get 7? You counted the non-shaded. 1, 2, 3, 4, 5, 6, 7 out of 16. Very good. 7 out of 16. 7 out of 16 is 0.4375. God, I'm so glad. Aren't you glad that you get to use calculators? Would you want to divide 7 into 16 longhand, long division? I sure wouldn't. All right, as a percentage, what does that turn into? 43.75%. Very good. Okay, number 6. What's the probability of spinning a 2 or 11? How many favorable outcomes are there? 2. 2 winners would be fine. 2 winning options out of how many total options? 16. That reduces to 1/8. 1/8 is 0.125 as a decimal. And what is it as a percentage? 12.5. Again, you could get that by multiplying by 100. All right. And then I love this last question. What's the probability of getting a multiple of 5? What does a multiple of 5 mean? 5, 10, 15, 20. Those are multiples of 5. All right. So how many winners is that? 3 winners out of 16 possibilities. 3 out of 16. 3 out of 16 is 0.1875, which is 18.75%. So making sure you read the directions, we want to write things as a fraction, decimal, and a percent, which turns out to be pretty easy with calculators. Thank God for calculators, right? All right, so turn the page. Probability, super nice. All right, number 4. A month of the year is chosen at random. Ladies and gentlemen, what are all the months of the year? January, February, March, April, May, June, July, and August. September, October, November, and December. Those are the months in the year. Oh, boy. All right. Lots of months in the year. What's the probability that those months start with a J? 3 out of 12. Very good. Which is what fraction? 1/4. Which is what decimal? 0.25. Which is what percent? 25%. Very good. I'd like to remind you that I am giving you PBS points for making sure you're taking notes as expected. All right. What's the probability that a month starts with a T? 0. 0 out of 12 is just 0, which is what decimal? 0. And what percent? 0%. Okay. What's the probability that a month has at most 30 days? Boy, at most, well, how many days? Oh, let's see. I'm going to figure out which ones have 31. Let's see. 30 days has September, April, June, September, April, June. 30 days has September, April, June, and November. All the rest have 31 except February with 28. 30 days has September, April, June, and November. All the rest have 31. Okay, so all the rest have 31 days. Oh, not April. Do you guys know that? Have you ever learned that poem? No? It's all we did when I was in school. 30 days has September, April, June, and November. All the rest have 31, except February was 28. So 31, 31, 31, 31, 31, and 31. So how many have at most 30 days? Well, let's see. February, April, June, September, and November have at most 30 days. At the highest, they have 30. All those pink ones have more than. So 5 out of 12. All right, 5 out of 12 is 0.4167. 67. I'm going to be so glad. All right. Let's look down at number 6. I want you guys to take a minute. Again, I like to kind of draw out what's happening here. We have a pencil box. It contains 5 red. 1, 2, 3, 4, 5 reds. It has 6 yellows. 1, 2, 3, 4, 5, 6 yellows. It has 8 blues. 1, 2, 3, 4, 5, 6, 7, 8 blues. 3 orange. And 2 purple. And all of these are in a pencil box. You can't really see inside. If one is chosen at random, so you reach inside and grab one of those pencils, what's the probability that you grab yellow? 6 out of how many pencils are in the pencil box? 24. Yes, 24 total. Yeah, so 6 out of 24 reduces to 1/4, so 0.25 and 25%. What's the probability that you get a blue or a purple? How many winners are possible? There's 8 blue and 2 purple, which is how many winners? 10 winners out of 24. I don't know what 10 out of 24 is. 0.4167. Hey, so 41.67%. All right, here's an interesting question. What's the probability that it's not orange? How'd you get 21 so fast? Yeah, 24 subtract the 3 not oranges. That's everything else. So that would be 21 out of 24. Very good. And 21 out of 24 is? Oh, it reduces, doesn't it? It reduces to 7/8, which would be 0.875 or 87.5%. Very good. Okay, now number 7, you can see that I put on their card deck. Back in Arizona, when I would ask kids, how many of you, ladies, how many of them played cards? Like 2 people would raise their hand. In my class of 40, all right? And I was astonished by that because I've been playing cards since I could hold them. Like, how many of you play cards? Good. Yeah, with a standard deck of cards. Yeah. Oh, good. Okay. So it's really important. A lot of kids don't actually know what makes up a standard deck of cards, so I added this picture here. You can see that it's 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. And you have the 4 different suits. And some are red and some are black. And that's important to know. We've got the red cards and black cards. Okay. How many cards in all? 52. 52. That's why it's called 52 card pickup. All right. If a card is chosen at random from a standard deck of cards, find the probability of drawing a queen. What's the probability of drawing a queen? 4 out of 52, which reduces to 1 out of 13. That, if you math frac that, 1 out of 13 is 0.0769, which would be 7.69%. What's the probability of getting a red 3? Two. There are 2 red 3s, 2 out of 52, which reduces to 1 out of 26. 52. Yeah. 1 out of 26 is 0.038. I'm going to say 5, which would be 3.85%. What's the probability of drawing a spade? 13. There are 13 spades out of 52 total cards. 13 out of 52 reduces to 1/4. So 0.25 or 25%. Okay, fantastic. Raise your hand if you think you get probability. Super easy, right? I love it. It's so easy. Okay, we want to look at one more thing and then we're done. The probability of a complement of an event. The complement of an event is the probability of the event not occurring. It's the opposite. Okay? It's like what we did here. What's the probability of getting oranges? Well, this is the complement. What's the probability of not getting oranges? All right? So it's sort of the reverse. Since the sum of all probabilities in a sample space is 1, the probability of an event not occurring is 1 minus the probability of it occurring. This little symbol, this little squiggle, that is the word not. There are lots of ways to calculate this, but we can do it both ways. All right, if the probability that it will rain tomorrow is 3 out of 8, so the probability that it will rain is 3 out of 8. That's what they're telling us. The probability that it'll rain is 3 out of 8 chances. What is the probability that it will not rain? And so there I'm using the little symbol. Yeah, so we could do 1 minus the 3/8 if you want. Let's watch. So 1 minus 3/8. What do you need in order to add or subtract fractions? Common denominator. Well, 1 is how many 8s? 8 8s. Minus 3/8 is 5/8, and that's what you said right off the bat with 5/8. Good for you. So we can do it mathematically, or you can say, well, we know that 3 are going to rain. How many are not going to rain? 5 chances are not going to rain, because there's a total of 8. 3 will rain. The others won't. Okay? So 5/8, there's lots of ways to think about it. All right. Number 9, if the probability that someone will win a game, so the probability of a win is 1 out of 24. What's the probability that they will not win? All right, so again, I'm using the little notation, the shorthand, that's the word not. If 1 out of 24 attempts is a winner, how many are not winners? 23. Very good. Lots of ways to think about that. You're either going to win or you're not. So you're not going to win 23 of those times. A number from 1 through 20 is chosen at random. What's the probability that it is not prime? Ooh. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Ladies and gentlemen, how many of all those numbers, which ones are prime? Because I don't know if you know this. Which ones are prime? 2 and 3 are prime. 5 is prime. 9 is 3 times 3, not prime. 7 is prime. 11 is prime. 13, 17, and 19 are all prime numbers. They are numbers that are divisible by themselves in 1, and that's it. For instance, 6 is 2 times 3. It has other factors. But 7 only is 7 and 1. That's all I got. All right? All right. So the probability that a number is prime, how many primes do we have? 8. We have 8 primes. All right? So what's the probability that it is not prime? 12 out of 20, which reduces to, divide by 4, 3/5. Okay. 3/5 is 0.6 or 60%. Oh, it didn't say you had to do that, but. All right. Do you guys have questions for me?
No.